Well, howdy, physics sleuths and inquisitive souls, and welcome again to another lecture of dynamic gravity. So I was just sitting here, still butthurt. Less butthurt though. That's progress. That's good. But still butthurt. I'm drinking and smoking and playing video games and doing all sorts of sinful things. And I thought, I don't think I ever told you guys about my finding on radioactivity yet. You see, it's really crazy too. I found this out just recently that Nikola Tesla, the other guy with that other dynamic gravity theory, right? He also believed this. In fact, he believed a lot of the same things that I believe with why I believe dynamic gravity is correct. You know, I hate to say it, but I might be forced to write his name on the paper and accept the Nobel Peace Prize one day, if I do accept it. I might not. Who knows? We'll see. Things come and go. But this will be a quick episode. I promise, guys. I promise. I know I've done that before. I've said, no, just a quick episode. I promise. I promise. And then like an hour, 2 hours long. And, and you're like, you lied, Sean. You lied. I promise. This time, just the tip, baby. Just the tip. So, let's break into this, shall we? Let's go into radioactivity. This is what this is, okay? Radioactive decay is just basically the larger atoms get, the more likely they are to not be stable and to decay, okay? And they do this in different ways with like alpha decay, where it shoots out like a smaller proton particle, whatever, beta decay. It looks like turning a neutron into a proton with an electron and an anti-electron or whatever. Gamma decay, I don't remember what that one is. Something about shooting out gamma rays. I'm not going to go into that one too much, but yeah, these different decays, right? And they know this. The larger the atom is, like uranium or plutonium, the more likely it is to decay. And so the natural consensus is like, well, clearly size is the limiting factor that's making instability with atoms and blah, 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 blah. Shut the fuck up. You know what you're talking about. And this never sat well with me. I remember in a physics class in college, and they told me this. They said, yes, radioactive decay, it's completely spontaneous. It's erratic. Nobody knows. It happens here and there, but not there, but here, but not there, but nobody knows. It's completely random. Completely random. And I'm like, bullshit. Nothing is random in this world. You just don't know what it is. And the further I dug into it, the more it'd be like, yeah, we have no clue. So it's not because the atom gets bigger, okay? You see, when the atom gets bigger, it does find equilibrium. And once it finds equilibrium, it's good. It's not coming apart. It's not going to come apart unless there is some force added to it to give it more energy to mess with its equilibrium state. Okay? As long as you have an atom, that is sitting, not being hit by any sort of radiation, photons, neutrinos, whatever, it will not decay. Does not matter how big it is, as long as it was able to find equilibrium and reach a state of existing. Now that equilibrium gets harder and harder to find as the atom gets bigger and bigger. That is definitely true. So the larger an atom gets, the harder it is to get it to piece itself together in equilibrium in a state that it's happy with and it wants to be like that. But once it finds that state, it will stay that way forever and ever and ever and ever and ever. Forever and ever and ever. Okay? And I know you guys are like, you're talking about, my physics book, shut up. You know what you're talking about. You think you're no more than me? Read my papers. Read all my other things that I have on this channel. I'm going to put all my papers in every single freaking description on every video. Read it, and you see where I'm at. And then we'll see if you still want to argue with me. Okay? So, I know what the source of radioactive decay is. Nikola Tesla did too. Yeah, he did. I'm going to show you, I promise. So, what it is this came about when I discovered not the internal structure of the electron, which I was last 2 videos ago, or not how the electric field were the last video, but a couple of videos ago I discovered neutrinos were, okay? Neutrinos are the exact opposite particle of an electron. So a neutrino and electron are identical, okay? Now, this causes, well, they're not exactly, they're opposites, so they kind of have varying properties. They're not replicas. They're totally different. But they're identical, they're similar, like your left hand and your right hand. So, that's what a neutrino is. It's basically a electron that was created from the proton of the nucleus that shifted during either fusion or fission, or some process came along and made the core, the nucleus of the atom shift, and it shifted in relative motion to the electrons, and so that's what creates a neutrino. That's what creates it, okay? Now, when the electron shifts in the presence or with the base of the proton, then you get an electron. That's how electrons are made, by electrons, okay? They weren't made from the Big Bang. You're stupid if you believe that. I'm sorry. I didn't mean to say that. I meant to say you need to read my papers more, and you need to watch my videos more, because you don't know what the hell you're talking about. Now, this is the way it is. That's how electrons are made. They weren't made in the Big Bang. They're made every time you make a photon that's the highest energy possible. If it's the highest energy possible photon, like just above a gamma ray, you get an electron that shoots out, and that's the highest energy you can get. Bam. You get high energy electrons, you can get muons, all this stuff. But, that's what it comes. So, you might be thinking, well, how does this relate to anything? What are you trying to teach me? What I'm trying to teach you. Oh, that's not good. Okay. Okay. What I'm trying to teach you is that neutrinos are created from nuclear fission and fusion. So they're coming from the sun mostly, okay? So they come from the sun. And just so you know, this definitely explains alpha and beta decay. I don't know about gamma decay yet. I don't know. I haven't looked into that a whole lot yet. I don't remember it. It's been like 30 years since I learned all this stuff. My memory's not that great. Now, so here's the nucleus of an atom, right? And the more you crimp together, the more they're like, oh, the more they don't like that, they want to split apart. No, that's not what happens. What happens, now I know this completely goes against what the weak nuclear force is, my son. Funny how they don't even know what that is. Funny how they don't know. They know it's there, they can measure it, but they don't know what's causing it. They just call it a force. That's not a force. What the weak nuclear force is, the force that lets the protons break away from the atom. But it's not an actual force. What it actually is happening is neutrinos are bombarding us constantly from all angles, billions and millions and trillions of them. Now, usually, as I explained in my thing on neutrinos, they have more momentum than an atom of uranium. So if a neutrino comes by and it has an atom of uranium, it doesn't bounce off the atom of uranium. No, the uranium atom bounces off the neutrino, because the neutrino is going the speed of light, and it has that much momentum from that. Okay? It's not that much more, though. It's not that much. It's only like 4 or 5 times higher than what you would need to move a uranium atom. It's not like an astronomically large number like you would think, because it's going so fast. It's really not. Okay? So, so neutrinos are coming by. Excuse me. They're coming by. And usually they move atoms out of the way, or they're in their cloud traveling form, and they just kind of envelop or go around things, split, go whatever. But sometimes, for whatever reason, they will score a direct hit. And because we know that electrons from 2 lectures ago are vortexes, that's all the electrons are. They're vortexes of electromagnetic radiation. That's it. That's all it is. It's not an actual physical particle. It's just a vortex of energy. That's all it is. And that's what a neutrino is too. And when they get force acted upon them, they normally want to travel and go at the speed of light in their cloud form. But when they have forces exerted on them, now they have to react to that and find equilibrium. And that's going to bring it down to closer to a point particle, depending on how much external forces are acting on this. Okay? Now, It's rare, but it's possible. The neutrino will hit an atom just right in a way where it will go from its cloud form into a point particle, penetrate into this atom, and it will hit one of the neutrons. One is it a neutron? I think it is a neutron. Yeah, it'll hit a neutron. Okay, and what a neutron is a neutron is a proton that ate an electron. So the neutrino will penetrate into the neutron and hit the actual physical part that's still there of that electron and bounce that out. Now, instead of having a neutron, you have a proton inside your nucleus. Well, guess what? Now your equilibrium is all destroyed and it has to re-equalize, and now it shifts and you have nuclear fission, and it breaks apart and it spits stuff out, and you have your different types of, radioactive decay, blah, 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 depending on what it's hitting and how it's interacting with it. Okay? Now, this is the source of radioactive decay, is neutrinos. And if you had zero neutrinos around or any cosmic particles or anything that could, add energy and mess with atoms, you would not have any decay. Mm-hmm. Now, these are cosmic particles. They come from the sun, star, whatever, bloop, bloop, bloop. And they're constantly, when they hit the atmosphere, they hit like ions and this and do-do-do, and they do this, process, and they have a very short lifespan and da-da-da, and they can do all these different things, right? And these are like, protons, they're in the pions, blah, blah, blah. They're neutrinos, blah, blah, blah. Muons, whatever. But neutrinos are the important thing. That's what's really causing I would say 99% of all atomic decay. Okay? Now, you might be thinking, you said something about Tesla. Yes, I did, didn't I? Here is probably the best statements of Tesla. There's a letter he wrote back. No. I don't think he was even alive back then. But he wrote this letter. All right. And this is basically him going off into, various things, and he's pooping on general relativity because he doesn't like general relativity like me. And he's pushing a little bit his theory of dynamic gravity right here, dynamic gravity theory. That's Tesla. He came up with it first. He couldn't put the pieces together. He didn't have enough knowledge of how the universe worked like I do now, 100 years later. If Tesla had access to my internet, he probably would have figured it all out, man, 100 years ago. He probably would have. If he just would have known a few certain key points and realized their relevance, he would have had it all figured out. But he didn't. So instead, his theory of dynamic gravity is essentially based upon ether and charges, and that's really all he says about it. He doesn't explain anything how it works and how this works or how this works or that or that. He doesn't know. He doesn't know. But I will say this. Cosmic. Let me see. I immediately start to search external agent, which, okay, here we go. Being perfectly satisfied that all energy and matter is drawn from the environment, it was quite neutral that when radioactivity was discovered in 1896, I immediately started to search for the external agent which caused it, the existence of radioactive positive proof that the existence of external rays. I had previously investigated various terrestrial disturbances affecting wireless circuits, and by them others emanating the Earth could produce a steady, sustained action that was driven to conclusion activating the rays of cosmic origin. So you could tell. You could say, listen, it's coming from the sun, but I can tell you because the Earth would be blocking things and it's happening all the time that it's cosmic. It's not just the sun, it's all the stars in the universe. They're spitting out this radiation in all directions, and that is interacting. It's adding energy into the atom, and that's what's causing radioactive decay. And I just kind of explained to you the exact process that Tesla did not know, but he did know that was happening. And you might be saying, so Tesla knew the cosmic rays created radioactive decay. But you're missing the even bigger point. I spent 10 years at least, 12 years trying to conquer gravity when I first figured out that Einstein was a tard. He didn't know what he was talking about. I was 18. And it was like 30 when I finally figured it out, right? And it all spawned from one singular thought. You think I'm bullshitting? No, I'm not. I was high on my ass on mushrooms, and I just had one thought in my head. What if gravity requires energy to sustain itself somehow as every other fucking known force in the entire galaxy does? That was it. That was my only thought that I had. And this is my only foothold that I pit firmly. And I'm like, I am taking this as fact. And from then, literally within an hour, I had almost everything of dynamic gravity completely worked out except for the math, which wouldn't come for another 8 years. Took me a long time. Took me a long time. But know this, child. I am the only human that has ever lived that can perfectly calculate gravity, dark matter, and dark energy with the same equation, and I can tell you what the hell it actually is and how it works on a subatomic level like no one can. Ever. So, that's a very important thought if you're going to figure out dynamic gravity. The understanding that all of the energy that an atom has to do the things it does comes from external sources. Tesla knew this. This is why he formed his theory of dynamic gravity 100 years before me, and this is the exact thought that I had as I formed it 100 years after him, completing its circle. Okay? So, just so you know, I know this seems kind of crazy. You've been told one thing by physics your entire life, and now I'm telling you, just hand waving into existence because that's who I fucking am, Father Physics. Whether you like it or not, I am what I am. Now, this perfectly explains everything, and this can lead to some very interesting research and breakthroughs that could potentially happen one day if we could ever shield or nullify neutrinos perfectly well, which we can't right now. I'm working on it. I'm trying to figure out how to generate gravity, directional gravity, but I'm working on it. I'm getting there, inching by inch, progress by progress, day by day, less butthurt by less butthurt. Now, that's where I wanted to go. I just wanted to explain this concept to you guys because this is a very important concept that kind of underpins all of physics that nobody understands but me and whoever watches this video and actually wants to listen to my words instead of just argue with me and fight me. So, with that, I told you to be quick. I promised. At that, I will leave you and I wish you a good day. Adios, muchachos. Bye-bye.
Like, subscribe, submit.